Hello ladies and gentlemen, welcome back to our online distance learning Algebra 2 here with Mr. Hagedorn. Today we're going to get started in our 9th unit of the year, Trigonometry. And we're going to start that today with Lesson 9.1, Right Triangle Trigonometry, which is the base of everything else that we're going to be going through in this unit. A couple of things I have up here before we get started. It says consider a right triangle that has an acute angle theta. The three sides of the triangle are the hypotenuse, the side opposite theta, and the side adjacent to theta. So that statement basically saying that everything in the triangle is in relationship to theta. Ratios of a right triangle side lengths are used to define 6 trigonometric functions. Those are sine, cosine, tangent, cosecant, secant, and cotangent of theta. So down below here, the first thing I'd like to do is I'd like to establish what those are and then go through the acronym that you see here, SO, CA, TOA. SO, CA, TOA is a simple way of reminding us of the trigonometric function and the sides associated with it. SO is sine equals opposite over hypotenuse, CA, cosine, is equal to adjacent over hypotenuse, and TOA, tangent, is equal to opposite over adjacent. Then cosecant, secant, and cotangent are reciprocals of those three functions. So the sine of theta, as we just said, is the opposite over the hypotenuse. The cosecant is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. The cosecant is the reciprocal of the sine, so that would be the hypotenuse over the opposite. The secant is the reciprocal of the cosine, so that would be the hypotenuse over the adjacent. And the tangent is the reciprocal of the cotangent, so it would be the adjacent over the opposite. Now again, how can you tell which of these sides you're relating to or which of these sides you're pertaining to as far as theta? It's always in the triangle in the relationship to it. So the side that is opposite the right angle and the longest side will always be your hypotenuse. The adjacent and the opposite are in relationship to theta. The adjacent side is the side of the right triangle that, along with the hypotenuse, creates theta. And the opposite is the side on the other side of the right triangle. Or it's the side that has nothing to do with the creation of theta. So now taking a look at a couple of examples, let's see how we would deal with this as far as solving a right triangle, or, as you see here, evaluating the 6 trigonometric functions of theta. So the first thing we have to take a look at is our right triangle. Notice there's only 2 sides to that right triangle, and we need all 3 in order to figure out the 6 trigonometric functions. So this goes back to the Pythagorean theorem. The Pythagorean theorem, if you remember, is a squared plus b squared is equal to c squared. Or, if they aren't labeled, the leg squared plus the other leg squared is equal to the hypotenuse squared. So in this case, we would have 3 squared plus 4 squared is equal to c squared, or in this case, c being our hypotenuse. So if we do the math here, that would leave us with 25 is equal to c squared, so c, or the hypotenuse of this right triangle, would be 5. So now that we have all 3 of the sides, and we have them in a relationship to the right angle and theta, we can come up with our 6 trigonometric functional values. So the first one is the sine. Remember, sine is opposite over hypotenuse, so in this case it would be 3/5, since 3 is opposite theta. Cosine would be 4/5, since 4 is adjacent to theta, and the tangent would be 3/4, as it's the opposite over the adjacent. Then the cosecant, remember, is the reciprocal of the sine, so that would be 5/3. The secant being the reciprocal of the cosine, would be 5/4, and the cotangent, being the reciprocal of the tangent, would be 4/3. So there we have our example given, finding the hypotenuse. Now, what if the missing side of our triangle is one of the legs? Then we would use the same Pythagorean theorem, but we'd adjust it in the following way. Instead of us worrying about putting the legs together, it would be c squared, or the hypotenuse squared, minus the leg squared, or a squared, is equal to b squared, or the missing leg value. So in this case, that would give us 5 square roots of 2 squared minus 5 squared is equal to b squared. So in this case, 5 square roots of 2 squared is 50, 5 squared is 25, so that would leave us here with 25 equals b squared. So our missing leg in this case would be 5. So if we take a look at this, our missing leg here would be 5. And once again, now that we know all three sides, we take them in relationship to theta. So in this case, the first one, the sine of theta, is the opposite over the hypotenuse, which would be 5 over 5 square roots of 2, which again, if you remember back to basic algebra, we are going to have to simplify that down by rationalizing the denominator, which would give us our final answer here of 5 square roots of 2 over 5, or simply the square root of 2 over 2. The next one is the exact same value since the adjacent and the opposite are exactly the same. So in this case, it would be the square root of 2 over 2. And the tangent in this case would be 5 over 5, which is simplified down to 1. So now the cosecant, remember, is the reciprocal of the sine. So in this case, it would be 5 square roots of 2 over 5, which would simply be the square root of 2. The secant, since the opposite and the adjacent are identical, would be the same, the square root of 2. And the cotangent, being the reciprocal of the tangent, well, the reciprocal of 1 is 1. So again, with this, you just have to remember basic algebra and how those would be found, and making sure that anytime you've got a square root in any part of your triangle, whether it's the hypotenuse or the sides, making sure that your final value has a rational denominator, no roots in the denominator. Okay? The last thing that I'm going to ask you to do here in our lesson for today is to solve our triangle. Now, to solve a triangle, you simply have to find all of the angle measures, and on top of that, you have to find all the side measures. That's what we mean by solving a right triangle. So if we take a look down at the bottom here, there are a couple reminders that I put there for you. The first one is the sum of the angles of a triangle equals 180 degrees. So with any missing angle measure, we have to remember that no matter what it is, the sum of all three angles is 180 degrees. And again, the Pythagorean theorem states that for the sides of a right triangle, a squared plus b squared is equal to c squared. So these are things, along with the trigonometric ratios that we've already learned in our lesson, that we are going to be using to solve our triangle. So if we take a look at this, the things that we need to find, or the things that we need to solve for, are we need to find angle B, we need to find side A, and we need to find side B. So the first one, angle B, is going to be relatively simple because it plays off of the fact that all three angles are going to add up to 180 degrees, and we already know two of them. Since this is a right angle, which is 90 degrees, and angle A is 54 degrees, we can take their sum and subtract it from the 180 to get our final answer. So in this case, we would take 180 minus 90 plus 54, and in this case, we'd come up with the fact that angle B is equal to 36 degrees. So in this case, it was relatively simple to solve that part of the right triangle since we were given 2 of the 3 angles. Now for side A, what I'd like to do is I'd like to use one of the trigonometric ratios we just talked about in the previous couple of screens. So in this case, since we know that angle A is 54 degrees and side A is the side opposite, and we know that the hypotenuse is 20, opposite over hypotenuse is the sine. So in this case, we are going to take the sine of theta, which in this case is 54 degrees. The reason that we're using that one is, well, because we know that it's 54 degrees. Then the opposite, which is A, we don't know, but we do know that the hypotenuse is 20. So I'm just going to erase this for a second so we have plenty of room for this. So now what we need to do is we need to figure out, using our calculators, what that would be. All right. So if we would plug that in, the easiest way to do this would be to multiply both sides of that equation by 20. It gets it out of the denominator and isolates A, and then we do the same thing to both sides, well, because it's algebra. So in this case, we would get A is equal to 20 times the sine of 54. Now when you plug that in, you're going to notice that it's kind of a long run-on decimal, so we're not going to use that long run-on decimal. We're simply going to round it to the nearest tenth, which in this case, side A would be equal to about 16.2. So now that we know A and we know C, we have 2 options. For B, we could use the cosine of 54 is equal to B over 20, or we could use the Pythagorean theorem to solve. Both of them work. Either one of them is a viable option. In this case, just to give you another example, I'm going to use the trigonometric way. So in this case, if we take this, we would get B is equal to the cosine of 54. And the reason we're using cosine is because side B is adjacent to 54, and that would be equal to B over 20. So similar to the one that we did before, but not exactly the same. So once again, in order to solve this, we're going to have to multiply both sides by 20. So if we do that, we would get B is equal to 20 times the cosine of 54. And again, if we punch that into our calculators, it's going to give us a little bit more of a run-on decimal. Again, we're going to round it to the nearest tenth. So in this case, the answer to that one would be 11.7. So if we take a look at those and we plug in our values, we'd come up with the following. Angle B is 36 degrees. Side A is 16.2 units. And side B is 11.7 units. So there you have it, ladies and gentlemen. Everything that you need to know for the basic parts of trigonometry. As we go throughout the rest of our unit, we are going to use these trigonometric functions in varying ways to solve for not only right triangles in trigonometry, but general triangles as well. All right, ladies and gentlemen, again, that's all I have for you for today. As always, stay healthy, stay safe, and Lord's blessings on your day, ladies and gentlemen. We'll talk to you soon.